Another very important reaction that actually we take under, carry on, or has improved under the heading of what? Reversible reactions. Sulfuric acid, it is said, is the king of chemicals, without any doubt. Because it is said, prosperity of a nation you can measure, gauge by the fact that how much sulfuric acid you prepare. Because it is said sulfuric acid is used almost in every industrial process, even in its own making. But sulfuric acid main uses are, this king of chemicals is used in making ammonium sulfate, the fertilizer that is so common and used for all the fruit gardens, orchids. But it is also used in batteries, car batteries, leather industry, textile industry, detergents, making an insecticide and pesticides, liquid soaps. Huge uses sulfuric acid has. Making of sulfuric acid is also not an easy process. That's why it is said prosperity of a nation, you can find out how much they prepare. An easy process, reason, reversible reaction, main reaction of it, the catalytic chamber reaction, basically the main reaction of it is reversible. Okay, sulfuric acid is a yellow oily liquid and such a strong acid it is in concentrated form that it burns everything. You leave it here and it comes from here. It takes away the skin and the bones and all that. Acid attacks, sulfuric acid is used. So making of sulfuric acid, large amount of sulfuric acid are needed by the world, and that's why nature has given us plenty of sulfur. Sulfur is a yellow element, powdered form element, pure element, and it is large amount sulfur deposits are seen all around the planet. Crust, earth crust it contains. In many places sulfur catches fire, has caught fire from years, and that is the reason the water coming out is in the form of hot geysers, because sulfur is in combustion mode downstairs in the earth crust. But many places it is still intact and it is constantly being taken out by a process, Frost process. Okay, sulfur is being taken out as such. Okay, uncombined it is. Sulfur, a group 6 element, oxygen, sulfur, selenium, tellurium, polonium, yellow powdered, non-metal. And this sulfur in the first step of contact process is simply burnt. This is what? Sulfur burning. And when sulfur is burnt, combustion, it produces what? Of course, sulfur will turn to sulfur dioxide, the toxic gas, SO2. The same SO2, that same sulfur that is in crude oil, and when it is burned, sulfur to sulfur dioxide, and atmospheric pollutant, air pollutant, acid rain. But SO2 has a use because it is used as a food preservative also. And SO2 is used as a bleaching agent. Bleaches the wood pulp to make paper. So it has good uses as well. But the wonderful use is sulfur dioxide is used in making sulfuric acid. But this sulfur dioxide is being prepared by combusting sulfur. Once the sulfur dioxide is prepared, sulfur dioxide gas need to be injected into the catalytic chamber. But catalyst is so expensive, like vanadium pentoxide or platinum, so this need to be cleaned, removed of any dust particles. And dust particles are being removed by using magnetic dust precipitator. You need to understand only in your MCQ, magnetic dust precipitator removes dust particles. Okay, sulfur dioxide is cleaned. There was an alternate process some years back. Sulfur dioxide was basically encountered with high energy steam, and the gas particles, dust particles were removed by steam, and later on the gas was dried by using concentrated sulfuric acid already prepared. But dust precipitator is easy thing, removes dust particle. Now this SO2 gas, which is cleaned of impurities, will not poison the catalyst on its surface, it is absorbing, reacts again with the air, the oxygen. And this reaction is facilitated by the catalyst platinum and turns to sulfur trioxide. Sulfur already oxidized here, a +4 oxidation state, goes +6. So this is not an easy reaction to carry out. Burnt already, has to burn more. And carrying out this process, it is reversible. Dynamic equilibrium achieved. So again, we need to find out how much pressure we need to use and how much temperature we need to use. For pressure, we count what? Moles. How many moles are here? 3 moles. How many moles are here? 2 moles. Why 3? 2 and 1, 3. Why 2? because coefficient is 2. So rule says high pressure will shift to the side with less moles. So high pressure will improve the yield, and high pressure will improve the rate as well. If a question asks single factor that improves yield and the rate, in this case you will say high pressure for any gaseous reaction will improve the rate, obviously for forward, for backward, because increasing the pressure, when you increase the pressure, gas particles come closer, Coulomb frequency increase, rate of reaction increase. But what about the yield? Yield of that side will increase, which has less moles. In this case, it is a product side. Okay, so less moles, and since there are 3 moles here and 2 moles there, and also we need to improve the yield and the reaction rate as well, so pressure has to be kept high. But in this case, you can notice it is normal pressure 1 to 2 atm or 2 to 3 atm, because other factors have already improved the yield. So to check the cost, pressure is normally not increased. Okay, this is also a compromise situation. But if a question asks, what about the pressure? You will say, obviously there are 3 moles and 2 moles, so high pressure is needed. And high pressure will improve the yield. When temperature come into the game, we look at the delta H, negative. In the forward side, if it is exothermic, backward is endothermic. So high temperature, reaction oppose the change. You increase temperature, reaction will decrease, and can decrease only by moving to the endo side, in this case left side. So high temperature is not needed. A low temperature will shift to the side which has delta H what? Negative. But a very low temperature may not be good because it improves the yield, but reaction is sluggish and slow. It needs kinetic energy, at least need a minimum heating temperature. So 350 to 450 like Haber process is kept as a compromise situation. So a temperature of 350 to 450 or 2 to 3 atm are a normal pressure, and a catalyst, vanadium pentoxide, 5 oxygen mean pentoxide, V, vanadium pentoxide, or platinum. Mostly vanadium pentoxide is applied, and we get what? A very high amount of sulfur trioxide. SO3 obtained, it means we have the gold, the precious than gold, because SO3 means sulfuric acid, the king of chemicals. SO3 directly can be added into water if you can control that reaction, but the reaction is highly fuming and explosive. So this is not the route taken normally. Sulfur trioxide is rather added into concentrated sulfuric acid that has already been prepared. By a small amount of sulfur trioxide and water, it can be mixed and sulfuric acid is prepared, and that sulfuric acid is added into SO3 and it turns into H2S2O7. What it stands for? Nothing. It is of no use. We call it as intermediate, something in between, transition state. We call it oleum, and this oleum is added into water, and the less explosive reaction yield what? H2SO4, sulfuric acid. So to summarize the situation, we have sulfur from the nature, extracted in large amount, this element, combusted in the first step to yield what? SO2, and SO2 need to be cleaned. Dust precipitator removes dust particles. So this is cleaning is done to avoid catalyst getting poisoned, and sulfur dioxide is reacted with fresh air in the presence of catalyst in 350 to 450 and 1 to 2 atm situation. Sulfur trioxide is obtained. Sulfur trioxide means sulfuric acid, because adding it to water, if you can afford your machinery, like Germany can do these things these days, and you can get sulfuric acid directly or indirectly. Sulfuric acid, the normal process is sulfur trioxide is added into sulfuric acid, already prepared. Okay, and it turns to an intermediate called oleum, and oleum is then added into water and produce what? Sulfuric acid. The king of chemicals is used in making the famous fertilizer, the black fertilizer, ammonium sulfate for food, for fruit crops, used in car batteries and leather industries. So you can notice that Le Chatelier rules and reversible reactions are tackled by smart chemistry. High pressure to shift to the less mole side, high temperature to the shift to the endothermic side, and we obtain what? The sulfuric acid. That is reversible reactions and sulfuric acid industry.